Okay, hi Miss Kotzer. So this is my third and final FRQ. A biologist is interested in studying the effect of growth-enhancing nutrients and different salinity or salt levels in the water on the growth of shrimp. The biologist has ordered a large shipment of young tiger shrimp from a supply house for use in the study. The experiment is to be conducted in a laboratory where 10 tiger shrimp are randomly placed into each of 12 similar tanks in a controlled environment. The biologist is planning to use 3 different growth enhancing nutrients, A, B, and C, and 2 different salinity levels, low and high. So the treatments that are going to be used in this experiment, so there's the nutrients and then the salinity. So there would be nutrient A with low salinity, and nutrient B with low salinity, nutrient C with low salinity, and then nutrient A with high salinity, nutrient B with high salinity, and nutrient C with high salinity. That would be 6 treatments, right? And to start out for the completely randomized design that will allow the biologist to compare shrimp growth after 3 weeks. So basically what I would do, I would get all 120 of my shrimp, right? And I don't really know how to handle shrimp, if I'm being 100% with you, but I guess you could assign shrimp a number, like 1 through 120, and then you could randomly generate numbers, or you could pick a random shrimp and then get every third or fourth or so-and-so shrimp until you would put them all, separated them into the groups. And because, sorry, I just got a really stupid text. Anyway, sorry. Because you have 6 treatments, and you want 12 tanks, you can give each treatment has 2 tanks, right? And assuming these are all not affected by anything else, so they're similar except for the treatments, you would have a treatment or 2 tanks with nutrient A and low salinity, 2 with nutrient B and low salinity, 2 with nutrient C and low salinity, 2 with nutrient A and high salinity, B and high salinity, and C and high salinity. So then you would end up with a completely randomized design with equal number of shrimp in each group and equal representation for all the treatments. Yeah. So give one statistical advantage to having only tiger shrimp in the experiment and explain why this is an advantage. So I would say the statistical advantage of having only tiger shrimp is that you don't have that many confounding variables. I mean, assuming you control the environment, you're not worrying about the different growth rates of different shrimp, or like, because they all came from the same place, but I guess it's not really related. You don't have to worry about that kind of stuff. Whereas like if you did have other types of shrimp, you might have to source them from somewhere else, and where they came from could affect their growth. They might have different preferences for habitat. So having a lot of different types of shrimp would make it harder to draw a conclusion definitively on the nutrients and the salinity. One statistical disadvantage of this, though, is that obviously if you only have tiger shrimp, it can only be generalized to tiger shrimp. So basically, where's my pencil? If you have, what am I trying to write? Oh, that's tweaking out. Never mind, I'm OCD, man. Okay, so if you just have tiger shrimp, you can't generalize that to the population of shrimp in general. You can just generalize it to tiger shrimp. Whereas if you had different types of shrimp, you might be able to draw conclusions about how these different treatments would affect all types of shrimp and not just tiger shrimp. So it does kind of not really go along with the effect of all this stuff on the growth of the shrimp as much as it's just about tiger shrimp. So it is, kind of a disadvantage there. But I mean, Okay, sorry, I lost my train of thought. Okay. So, the advantage of having just tiger shrimp is also the disadvantage because even though like it does limit